Far beyond the orbit of Saturn, where sunlight struggles to reach, lies Neptune, the eighth and farthest planet from our Sun. This icy giant, a shimmering blue orb in the vast darkness, holds many secrets yet to be fully understood. Discovered in 1846, Neptune challenged our understanding of the solar system's edge. Its discovery wasn't just a triumph of observation, but a testament to the power of mathematics. Neptune, a realm of icy clouds and supersonic winds, is a testament to the universe's capacity for both beauty and raw power. Unlike the rocky terrains of Mars or the swirling gas giants like Jupiter, Neptune represents a different class of planet altogether, an ice giant. It's a world where temperatures plummet to unimaginable lows, and the very composition of the atmosphere differs greatly from our own. While we think of water ice when we imagine ice, Neptune's ice is far more exotic. This is Neptune, a world of mystery, a world of extremes, and a world that continues to captivate our imagination as we strive to unveil its secrets. Neptune's story, like that of all planets, begins billions of years ago in a swirling cloud of gas and dust known as the solar nebula. As gravity drew this cosmic dust together, the nascent sun ignited at the center, bathing the surrounding disk in light and heat. Within this maelstrom, particles began to collide and stick together. Over millions of years, these clumps grew larger, forming planetesimals, the building blocks of planets. In the colder, outer regions of the solar nebula, beyond the frost line, where temperatures were low enough for volatiles like water, methane and ammonia to freeze, Neptune began to take shape. These frozen gases and ices accreted onto the growing protoplanet, eventually forming the massive world we see today. Unlike the rocky planets closer to the Sun, Neptune's icy composition gives it a much lower density, despite its immense size. This process, the gradual accumulation of icy particles, is what distinguishes Neptune and its fellow ice giant, Uranus, from gas giants like Jupiter and Saturn. It's the reason why Neptune's atmosphere, though composed primarily of hydrogen and helium like its larger counterparts, takes on a distinct blue hue, the result of methane absorbing red light and reflecting blue. For centuries, Saturn held the title of the ringed planet, its majestic rings captivating astronomers and stargazers alike. Yet, hidden in the depths of our solar system, Neptune too possesses a system of rings, although far fainter and more delicate than its more flamboyant neighbor. Neptune's rings are not the solid, continuous structures they might appear to be. Instead, they are composed of the clumps of icy dust and debris, shepherded into arcs by the gravitational influence of small moons. These ring arcs, the most prominent of which is named Liberté, appear as brighter segments within the ring system. The discovery of Neptune's rings was a triumph of both observation and scientific deduction. In the 1980s, as Voyager 2 embarked on its historic flyby of Neptune, it confirmed the existence of these faint rings, revealing their intricate structure and composition. For much of history, our understanding of the solar system ended with Pluto, a small, icy world discovered in 1930. However, in 2006, the International Astronomical Union redefined the definition of a planet, and Pluto was reclassified as a dwarf planet. This reclassification was not a demotion, but a recognition of the distinct characteristics that set planets apart from other celestial bodies. According to the new definition, a planet must orbit the Sun, be massive enough to achieve hydrostatic equilibrium, a nearly round shape, and have cleared its orbital neighborhood of other objects. Pluto, while meeting the first two criteria, shares its orbit with a multitude of other objects in the Kuiper belt, a region of icy bodies beyond Neptune. Neptune, on the other hand, reigns supreme in its domain, its gravity having cleared its orbital path of any significant debris. With Pluto's reclassification, Neptune assumed the mantle of the final frontier of our solar system, a sentinel standing watch at the edge of the Sun's gravitational influence. Yet, Neptune is far from the end of the story. It marks a transition point, a gateway to the vast and mysterious realm of the outer solar system, a region teeming with icy worlds and remnants from the early solar system.